In this lecture session, let us observe how a given square matrix A can be represented as the sum of a symmetric matrix plus a sum of a skew symmetric matrix. Right? So let us revisit the definitions of symmetric and skew symmetric. So what is a symmetric matrix? A symmetric matrix is a square matrix where the elements on either sides of principal diagonal are equal. For example, I have the principal diagonal here, the elements on either sides of principal diagonal are equal. So these two are equal, and then I have these two elements are equal. So the elements on either sides of principal diagonal are equal. So this is a symmetric matrix. Now what is a skew symmetric matrix? It is again a square symmetric matrix, a square matrix where the elements along the principal diagonal are 0, but the elements on either sides of the principal diagonal are equal but are of opposite sign. That means if I have 2, I have minus 2 here. If I have 3, I have minus 3 here. If I have 6, I have minus 6 here. So this is a skew symmetric matrix. So now the property states that any square matrix A can be represented as a sum of symmetric and skew symmetric. So how can this be done? So let's take an example. So let me consider a 3 cross 3 matrix A. So I have a matrix A which is 1, 2, 4, minus 2, 5, 3, minus 1, 6, 3. So what is the goal? The goal is to express A as the sum of symmetric plus skew symmetric, the sum of symmetric and skew symmetric matrix. To do that, let me first write the transpose of matrix A. So how do I get the transpose? I get the transpose by writing rows as columns or by writing columns as rows. So the first column is 1, minus 2, minus 1. So I write it as the first row. I have the second column. I write it as the second row. I have the third column, 4, 3, 3. Write it as the third row. So next, what do we do? I add these two matrices. So A plus A transpose. So what is A plus A transpose? I need to add the individual elements. So 1 plus 1 is 2. 2 plus minus 2 is 0. 4 minus 1 is 3. Next, I have 0 here. Minus 2 plus 2, 5. Plus 5 is 10, 3 plus 6 is 9, minus 1 plus 4 is 3, 6 plus 3 is 9, 3 plus 3 is 6. So I have 2, 0, 3, 0, 10, 9, 3, 9, 6. Okay? So next, I do A plus A transpose by 2. So therefore we get 2 by 3, 0, 3. So A plus A transpose by 2 we get 1, 0, 3 by 2, 0, 5, 9 by 2, 3 by 2, 9 by 2 and 3. Right. So what do we observe? If I observe this matrix, a matrix A plus its transpose will actually give me a symmetric matrix. So observe, these are the elements of the principal diagonal. The elements across the principal diagonal are equal, 0, 0, 3, 3, 9, 9. Okay? Right? So I have divided the values by 2. So essentially, adding A and A transpose will give me a symmetric matrix. Very clear. So these two elements are the same. These two elements are the same. These two elements are the same. So this is a symmetric matrix. Next, let us subtract A and A transpose. So I get 1 minus 1 is 0. 2 plus 2 is 4. 4 minus 1, so that is 5. Minus 2 is minus 4. 5 minus 5 is 0. 3 minus 6 is minus 3. And then I have minus 1 minus 4 is minus 5. 6 minus 3 is 3. 3 minus 3 is 0. So A minus A transpose will give me a skew symmetric matrix. So observe the principal diagonal elements are 0 and the elements on either sides of the principal diagonal are equal but they are of opposite sign. Minus 4 plus 4, minus 5 plus 5 plus 3 minus 3. Right? So now I have A minus A transpose by 2. I divide the values by 2. So we get 0, 2, 5 by 2, minus 2, 0, minus 3 by 2, minus 5 by 2, 3 by 2 and 0. Now why we divided them by 2? Because I need to get A, right? So my goal is to get A or to write A as the sum of symmetric plus skew symmetric matrix, right? So let me call this matrix as S and let me call this matrix as S dash. So let me add S and matrix S dash. So what do we get? We get 1 plus 0 is 1, 2 and then 3 by 2 plus 5 by 2 is 4. Next minus 2, 5 plus 0 is 5. 9 by 2 minus 3 by 2 is 6 by 2 which is 3. Then 3 by 2 minus 5 by 2 is minus 2 by 2 which is minus 1. 9 by 2 plus 3 by 2 is 12 by 2 which is 6. And then I have 3 plus 0 is 3. So I end up getting matrix A. So how do I get matrix A? We get matrix A. So essentially, by representing A as the sum of symmetric plus skew symmetric. That is, of this form, A plus A transpose by 2 plus A minus A transpose by 2. Okay, so A plus A transpose will give me a symmetric matrix. A minus A transpose will give me a skew symmetric matrix. I divide both of them by 2 and add them, I get matrix A. Right? So a given matrix can be represented as the sum of symmetric and skew symmetric matrix in this way.